Here's another shortest path example, and we're going to go again from vertex S to vertex T. The numbers indicate hours of travel. So for example, to go from S to A is going to take 3 hours of travel. Okay. So let's do what we've done in the previous examples, and let's consider the vertices that are one edge away from S first. So in other words, from S, there's one of two vertices has to be in the path basically. Either has to be A or G. So with A, getting to A is going to take 3 units, okay, or 3 hours, sorry. S to G is going to take 4 hours. So I'm just going to put the numbers here in blue. Okay. Now let's consider the vertices now that are sort of another edge away. Okay, so a bit further away now from A and G. So we've got basically the vertices that can now be reached from the vertices that we've worked out. So we've worked out A, we've worked out G. So let's consider the vertices that are now reachable from A, namely B, E, K, and H. Okay, and so let's from A going to B. A is 3 hours plus 6, that gives us 9 hours. Okay. 3 plus 5, okay, so going now to vertex E, 3 plus 5, that gives us 8 hours. Okay. Now to K, we can either go via A, so A to K is, so 3 plus 4 is 7, or we can go via G. So G to K is 4 plus 5 is 9. So 3 plus 4, 7. So we choose the lower of the two values. And H, we can either go via G. So G to H, 4 plus 6 is 10. Or we can go via K, but 7 plus 4 is 11. So 10 is it there. Okay. Now let's consider the next set of vertices. Okay, so the vertices that are now reachable from H, K, E, and B. So we've got D and we've got C. Okay, so 9 plus 7, okay, that's 16 hours. Or we can go to C via E. Okay, 8 plus 4 is 12. So we put the lower, again, the lower of the two numbers, or the two values that we've worked out. Okay. And to get to vertex D, okay, we can either get to vertex D from E, so we can go E to D, so 8 plus 8 is 16, or we can go to vertex D from H, 10 plus 5 is 15. Okay. Finally now, to get to vertex T, okay, so this is our destination vertex, we can go via C, so 12 plus 3 is 15, so it's 15 hours, or via D, 15 plus 9 is 19 hours. So clearly from C to T is the shorter, or the one that takes the least amount of time. So that's going to be 15. Okay, 15 hours. Now we need to work out the actual path. That was the path that results in the shortest amount of time taken. Okay. Alright, so again, we're going to backtrack. So starting at S, we're going to end at T. If you can remember some of the edges that you've used, that will actually speed it up. But let's go through the process of backtracking. 15, okay, minus 3 gives you 12. 15 minus 4 will not give you 15. So it can't be this edge here. Okay, so the edge that's part of the shortest path is edge CT. Okay. So from C, again, we've got two paths back from C. We've got 12 minus 7, that gives us 5. Okay, but we've got 9 here, so it can't be this edge. Or 12 minus 4 is 8, and we've got 8 here next to vertex E, so it's this edge here. Okay, now from E, okay, going back, 8 minus 3, well that doesn't work. Okay, so that's 5, we've got 9 there. 8 minus 8, well that's 0, we certainly don't have 0 there. Okay, 8 minus 7, well that doesn't work. Okay, because 8 minus 7 is 1 and we've got a 7 there. 8 minus 5 is 3 and we have a 3 there. So this is part of the path as well. Okay, and then finally 3 minus 3 is 0. Yep, and that works. So the shortest path is S. Okay, so now trace it through. SA, E, C, and T.